Hello everyone, let's go ahead and continue with combinatorics. The next thing that we're going to look at is called permutations. Now, permutation of a group of symbols is any arrangement of those symbols in a definite order. Usually what we're asked for is how many permutations are possible. So let's go ahead and take a look at a particular situation here using the letters of the word math. So we have M-A-T-H. Okay, there's our group of symbols composed of 4 symbols. They're arranged in a particular order, and because of this particular order, it makes a word called math. So what we're going to do then is let's kind of get a visual idea of what's happening here. We're trying to take a look at all the different possible arrangements of these symbols. Now, one possible way that we could approach this is using a tree diagram. Okay, and the tree diagram is going to be quite nice in the sense that it'll give us an idea of how we want to think about things, but at the same time, the disadvantage of the tree diagram is that it's just going to get too big sometimes. So we're going to have to go ahead and even simplify some of those thoughts, but let's take a look at the tree diagram first so that we have a visual understanding of what's happening. Now, I'm going to call this the first event, and the reason why I'm going to call that the first independent event is because, of course, you're going to have 1, 2, 3, 4 letters. So you got 4 letters, so any one of these letters can take the spot of the first letter in a particular, in the arrangement of the 4 letters. So it could be M, it could be A, it could be T, or it could be H. So what I'm going to do then is I'm going to say that in this first event there are 4 possibilities, 4 letters that can actually go into this first spot of the word composed of 4 letters, M-A-T-H. Okay? Now, if we go ahead and take a look at what happens after we choose M, say for example, the only 3 letters that we have left are A, T, and H. Now, any one of those 3 letters could go ahead and fill in a spot for that second letter. Now, if I wanted to go ahead and draw the tree diagram or the branch for this here, of course, it would include M, T, H. Again, it would still only have 3 branches. So for each one of these options, there's only 3 branches. And if we think about what's happening, after here's the 4 letters, you choose 1 letter. There's only 3 letters that you can choose from now, so there you go. And then after that, you take another letter. There's only 2 letters left, so that's why there's 2 letters remaining and 2 possible here. And then after that, you take 1, and then you're left with 1 letter. Okay, so now if we go ahead and take a look at this, it's 4 times by 3 times by 2 times by 1, because we're talking about how many branches altogether in each tree diagram. And boy, that's 4 times 3, that's 12 times by 2, that's 24. Notice even with small numbers, we're only talking about 4 different possible letters here, and making all the different permutations of those letters, we're dealing with 24 branches that extend all the way out here. So the tree diagram in that sense is going to be much more complicated to draw, although initially it's important so that you can see where these options are coming from. So what we know then is that if we want to take the total number of permutations of the word math using all 4 letters, well, that's just going to be 4 factorial, because this is just going to be 4 times by 3 times by 2 times by 1. Now let's go ahead and think a little bit more. Okay, let's say what happens if we want to go ahead and take a look at the total number of permutations of the word math, but this time we're only going to be using 3 letters. So you got 4 letters, M-A-T-H, but in the end you're only looking at how to go ahead and create an arrangement of 3 letters using those 4 letters. Okay, so for example, if we go ahead and use the same idea then, well, we can still go ahead for this first letter, choose M-A-T or H. Then the second letter is still going to have 3 possibilities. The third letter is still going to have 2 possibilities, and that's it, you stop. Because what we're doing is we're looking for the permutations of the word math, but we're only using 3 letters. So therefore, what we come out with is the same thing. It's 4 times 3 times by 2. Of course, notice this time there's no 1 in there. But we can still go ahead and write it as 4 factorial divided by 1 factorial, so that we can cancel out the 1's, and we can come up with, again, 4 factorial. Now let's continue with this and say what happens if we go ahead and look at the total number of permutations of math using only 2 letters this time, And I think everybody's kind of seeing and getting an idea of what's happening. So in other words, we only have 4 times it by 3. Well, that's the same thing as 4 factorial divided by 2 factorial. And then the total number of permutations of math using only one letter, well, that's going to be 4 factorial divided by 3 factorial, because there's only 4 different letters that we can use. So I think we're hopefully seeing a bit of a pattern here. If we want to go ahead and calculate the total number of permutations of a particular number of symbols using only so many of those symbols in your permutation. So what we want to do then is we want to come up with some kind of formula, or at least some way that we can go ahead and always calculate this without having to draw the tree diagram, and even to a point where we might not even need to consider how many of these options using this underlying method that I'm using here. So given n objects, take n r at a time, the total number of permutations seems to be what? You go ahead and take a guess, and we'll go ahead and consider it the next time that we meet in class. Now, some of these questions can get very tricky. This is very basic right now. So we'll go ahead and take a look at some of those more complicated ones together. Now, again, remember that the permutation is really the arrangement. We're usually being asked how many of those permutations there are. And then in addition to that, you start off with a certain number of symbols or objects, let's say, and then after that, in addition to finding out the total number of permutations of all the objects, things get a little bit more complicated when you start talking about taking a look at only so many of those objects at a time. Okay, and we'll go ahead and take a look at some of those questions in class so that we have a very clear understanding of how we can calculate then the total number of permutations of a particular arrangement given r objects at a time. Okay, so fill this in. We'll see if everybody's got the right idea, and we'll see you the next time in class. Okay, bye-bye.